Hello everybody, welcome to the AMC 10 course by Math Katana. Throughout this course, we will walk you through the most important topics in the AMC 10 and 12 to help you score better. This is the first in the series of videos, and we'll be covering algebraic manipulations in this video. You can always find the handout and all the lessons and their complete course on the Math Katana website, which is linked in the description. Okay, let's get started now. So today we're talking about algebraic manipulations, and here are some core identities and expansions that you should already know. If you don't know, then you can take a moment to pause the video and keep on working through the problems here. Okay, I'll assume that you've looked over them and understand them now. Okay, so these are some of the most important factorizations, but what I really want to talk about is how to use reciprocal powers. Reciprocal powers are expressions sort of like that. And why are they useful and why are they beautiful? It's because if we square x plus 1 over x, if we square that, then by the squared identity, then we'll get x squared plus 2 times x times 1 over x is plus 1 over x squared, which is equal to x squared plus 2 plus 1 over x squared. Notice that the x and the 1 over x cancel, so it can help us with many different problems. Okay, to put this into use, let's try the 2007 AIME 10A problem 20. The problem reads, suppose that the number a satisfies the equation 4 is equal to a plus 1 over a. What is the value of a to the power of 4 plus 1 over a to the power of 4? Okay, so we know that a plus 1 over a is equal to 4, and we want to find a to the power of 4 plus 1 over a to the power of 4. Okay, so what can we do here? Well, let's square this. It'd give us a squared plus 2 plus 1 over a squared is equal to 16, which when rearranging a squared plus 1 over a squared is equal to 14. This was motivated once again because a and 1 over a cancel. And this becomes, if we square again, a to the power of 4 plus 2 plus 1 over a to the power of 4 is equal to 196. So we conclude that a to the power of 4 plus 1 over a to the power of 4 is equal to 194. And that is our final answer. So this problem was mostly just squaring and noticing that the two different reciprocals cancel. And it's also a good way to demonstrate that knowing your own factorizations helps and will help you solve many problems really quickly. So now let's move on. Okay, here's some key factorizations. The most important one in AMC is probably x squared minus y squared is equal to x minus y times x plus y, which you can prove by expanding both sides. And this is simply just x squared minus xy plus xy minus y squared, and these two just cancel. And two other pretty important ones for the AMC are the difference of cubes and sum of cubes. Note that we can remember this by knowing that if it's the sum, then we have the plus, and if it's the minus, we have the minus over here. Okay, now let's try this example. Given that x minus 1 over x is equal to 4, find x cubed minus 1 over x cubed. Okay, so let's remember our expansion of cubes. Say that we have a plus b and we want to cube it. Then that'd give us a cubed plus 3a squared b plus 3ab squared plus b cubed, right? And so if we let a equal x and b equal 1 over x, negative 1 over x, then we can just plug this into there. We know that a cubed is x cubed plus 3a squared is just x squared, b is negative 1 over x, plus 3, a was once again x, b squared is negative 1 over x squared, plus negative 1 over x cubed. Okay, and now if we multiply out, we have x cubed minus 3x plus 3 over x minus 1 over x cubed. Okay, and notice that these two are exactly the terms that we want. And we got this by having x minus 1 over x cubed is equal to this. And we know that x minus 1 over x is 4, so this is going to be 64. Hold on. 64. Okay. And notice that these two terms we can factorize as negative 3 times x minus 1 over x. And we know that this is 4, right? So, therefore, what can we do now? We can just put the 4 inside with the 3, right? And so this would give us negative 12. So 64 would be equal to x cubed minus 1 over x cubed minus 12. And if we move this over to this side, x cubed minus 1 over x cubed would be equal to 76. Great. Okay, now let's move on to the next one. The next one talks about higher power factorizations. This doesn't occur as much in the AMC, but it will occur in the AIME and sometimes in the final 5. So the sum of the odd powers would be x plus y times the signs are alternating between them, and they're just as the terms shown here. And the difference of powers, just remember that the signs are always the same. They just give always plus on this side though. And another one is Simon's favorite factoring trick, which was named after AOP's community member Simon R. And this is called his favorite factoring trick because he discovered it and was the first to popularize using it. Okay, and we can generally apply this factorization whenever we have x, y, and xy. For example, if I had a factor xy plus 3x plus 9y, then that'd give me, then what I would do is I notice that there's a 3 here, there's a 9 here. So we can write x plus y plus, and since I have a 3 in the x and I want to multiply a 3 into the x, I put 3 on this side. And I have a 9 in the y and I want to multiply a 9 into the y. So I would put 9 here. And this would be equal to xy plus 3x plus 9y plus 27. And so I would factor this as x plus 9 times y plus 3 minus 27, since we had to add 27 on this side. This helps when solving a lot of Diophantine equations, which we'll talk about later in the course as well. And next up is solving some algebraic equations. Now, you may think that this is really easy, because we just move x to one side and try to do everything. But a lot of really hard problems can arise from this, and it's also really fun to look for the symmetry. And here are some of the 9 most common algebraic equation solving methods. You can look over it yourself when you pause the video, but we'll move on to the next problem for now. Okay, and the next problem comes to us from the 2000 AMC 12 problem 20. The problem reads, if x, y, and z are positive numbers satisfying x plus 1 over y is equal to 4, y plus 1 over z is equal to 1, and z plus 1 over x is equal to 7 over 3, then what is the value of x, y, z? Okay, so let's try this problem now. Notice that if we multiply all of these, we have x plus 1 over y times y plus 1 over z times z plus 1 over x. Then when we expand the first two, gives us xy plus x over z plus 1 plus 1 over yz. Now if we multiply that by z plus 1 over x, that gives us xyz plus x plus z plus 1 over y plus 1 over z plus 1 over x plus 1 over xyz, which is equal to xyz plus 1 over xyz plus x plus y plus z plus 1 over x plus 1 over y plus 1 over z. And what motivated us to multiply all of these is once again the reciprocals, because they always cancel out. So we see that we have what we want here, xyz here, right here. And when we multiply these, we knew that this is equal to 4, this is equal to 1, and this is equal to 7 over 3. So if we multiply that, that's 28 over 3. So we can write 28 over 3 on this side. Okay, but what else can we do? If we add all three of these equations, then we get x plus y, hold on, x plus y plus z plus 1 over x plus 1 over y plus 1 over z, which is exactly what we have over here. So if we add all of these, then we get 5 plus 7 over 3, which is 22 over 3. Okay, now if I move this over to this side, then that gives me 6 over 3. So, which would be equal to 2. So we have 2 is equal to xyz plus 1 over xyz. And we know that we're very close because this is just xyz and we're looking for xyz. So if I let a is equal to xyz, then a plus 1 over a is equal to 2. And this is just a quadratic, so this becomes a squared minus 2a plus 1 is equal to 0. So a minus 1 squared is equal to 0 and a is equal to 1, or xyz is equal to 1 as our final answer. Great. Well, that wasn't so hard, and that was a problem 20 on the AMC 12. So we can see that algebraic manipulations are very important. Okay, now let's do an example from the AIME, which will be our last example today. It says, find the positive solution to 1 over x squared minus 10x minus 29, 1 over x squared minus 10x minus 45, minus 2 over x squared minus 10x minus 69 is equal to 0. Now, this problem is a great example of substitution. So this is motivated because we can see the x squared minus 10x on all three of these. So if we try to multiply everything out, then that would be horrendous because there's a bunch of x to the power of 6 and x cubed coefficients, etc. So let's try substitution. What if I let x squared minus 10x minus 29 equal a? I like the letter a more. Okay, so this would become 1 over a plus, note that this is negative 45, so 1 over a squared minus 16, because negative 29 minus 16 is equal to negative 45, minus 2 over x squared, a minus, since negative 29 minus 40 is equal to negative 69, we have negative 40 here, and this would be equal to 0. Great. Oh, why did I have squares? Sorry. This is just normal a. Okay, and now if we multiply everything out, then this becomes a minus 16 times a minus 40 plus a times a minus 40 minus 2 times a minus 16. If we multiply everything out, and this would all be equal to 0 since this side is just 0. Anything multiplied by 0 is just 0. And why is this better than if we had just multiplied x squared straight out? Because this only gives us a quadratic, which we have the quadratic formula for. Otherwise, why would it exist? Okay, now if we expand this, this becomes a squared is minus 56x plus 640 plus a squared minus 40a minus 2a squared plus 32a is equal to 0. And now we can combine like terms. So we have a squared minus 2a squared, so we can kill all of those since they just cancel each other. And this will leave us with negative 40a, 32a, and negative 56a, which become negative 64a. And if we move that to the other side, we have 64a is equal to 640, because that's the only constant term here. And this would give us a is equal to 10, and if we bring that back up here, we can find x. So if I put 10 is equal to x squared minus 10x minus 29, then x squared minus 10x minus 39 is equal to 0, and then x minus, if we factor this, which we can do because it's a quadratic, x minus 13 plus x plus times x plus 3 is equal to 0, and this would give us a negative solution. X is equal to negative 3, and we want the positive solution, So we just take x is equal to 13, and that would be our answer. Thank you so much for watching the first episode of the AMC 10 crash course from Math Katana. Look out for the upcoming videos which will cover all the topics you'll need to ace the AMC 12. You can always look for our videos on our website, which is linked in the description, and make sure to like and subscribe if you learned something new. Thank you so much.